Okay, so I just got some questions from Connor on some topics. One of them is smoke test. And this term has been introduced in the midst of a semester where we've also talked about, testing more broadly. And I thought I had a nice slide for it right here, but it's probably in this, no, it's in neither. Okay. Best practices testing. There we go. That's the slide I'm looking for. So it's in the context of testing more broadly that I've used this term smoke test. And you may recall this notion of the V test model, but it's this idea that there's multiple types of tests that have different roles in the project, right? They play different roles in the ecosystem of the project. Unit tests test sort of low-level design and implementation. Integration tests test how things plug together, that they play nicely. Somewhere in between is unit integration tests, where you're testing something together with the things that it depends on. System tests or testing like user scenarios across the system, like user stories, right? And acceptance test might be a type of system test that's used to determine whether or not the project's accepted. So I introduced all this, and you might be forgiven wondering, like, where are smoke tests? Like, I don't see that, right? Smoke tests are very different from these sort of things. The role that smoke tests play is very different than the sort of tests shown here on the right side of the figure. Why do I say this? The tests on the right side of the V are designed to try to help locate defects within the runtime of it. They're designed to test the system and make sure that it meets requirements. That's kind of up here with system tests, that it's meeting requirements, or that it meets that the design has been properly implemented. That's more the role of unit tests. It's designed to try to find defects within the system to be fixed, right? We're trying to use this to improve the quality of the system, to identify defects. It's not the only role testing plays. Testing plays also roles in noticing usability issues, plays roles in identifying non-functional problems like performance issues, reliability issues, but things that wouldn't be called a bug or a defect, but get in the way of a quality experience. But tests are designed to allow us to identify cases where the system is not operating according to plan. The role of smoke tests is different. Smoke tests are designed to help validate, build confidence that the latest release of the code base, the latest merge into main or master, is in fact in a sane state, is in a state that it will basically deliver, it'll basically be acceptable for work by the developers and testers. And that's a mouthful. Let me explicate that a little bit more. Smoke test, the goal of it is to assess whether this latest merge into main has left the system in a sufficiently stable state, sufficiently usable state to allow development to proceed. That does not mean that the system is defect free. Does not mean that there's no problems with the system in certain areas. But the question is the system in a sufficiently basic stable state that it's worth people pulling to use for further development. To extend further, to pull those changes, to integrate those changes with their branches. Imagine that your latest merging domain has broken the ability to log into the system. Can you imagine that, Jason? Or imagine that it's, it's corrupted the database in some way. So it leads to an inability for the developers to run system level tests. Or imagine that it leads to, a complete breakdown of the ability to use any feature from the main page of the application, or most of the features. In that case, that merge into main is not fit to be pulled by others, because it will get in the way. If they get that code, it will get in the way of them doing their work, whether they're testers or developers. It'll get in the way of them being able to push forward with the system. So the goal of smoke tests is to flag if a merge into main is so broken that you need to roll it back. That you need to go back and fix those things before merging it into main. And it can happen. There are times where it will so break the system that it would deliver negative value to everyone in the team to pull that. And you want to tell them basically, hey, it's not ready for pulling. It's not fit for pulling. So this is testing fitness for being pulled. I'll just say pull. All right. By people. Is this code base in the same enough state that you want to stick with it? Now, you may wonder, well, wait a minute, why do we need a smoke test? Let's just run these tests. And if it passes these tests, then we view it as, and that's not a crazy idea on the face of it. The problem is that the system could be fit for pulling while it still has some defects in some areas. There might be some unit tests in a certain area of it. There may even be some integration tests that have to be worked through. That's the job of the testers to find. And that doesn't mean the system's not in a state worth pulling. It just means there's some work to be done by the testers to identify these things and by developers to track down the problem and fix it. So generally, fitness for pulling, you don't want to assess it by running all the whole suite of tests, because that's going to be an overly restrictive criteria. It will lead you to reject a lot of contributions to main that, yeah, they have some defects, but they're still fit enough for people to start building on them, even though there's some issues still to be tracked down by testing and development. There's some exploratory testing to be done further. There's some development, debugging that has to be done. So generally a smoke test will only test some so it'll consist of some system tests at a high level that will check things like, can you log in? And does the system from the login, is it something where you can access a few features? It'll make sure the system is able to read from a database and load in information. The most basic of functionality. And if you don't see that functionality, you'd be willing to declare it unfit to be pulled. Like you'd be willing to roll back that check-in command. That's a pretty heavyweight thing, saying, no, wait a minute, this merchant domain is unacceptable, let's roll it back until you fix these things. And that's the goal of smoke tests, to assess that. Yes. So Jason.
You said that the point of a smoke test is to see if it's fit for pulling. In some of our, I guess, workflows, we don't pull from the main branch, we pull from the development branch.
Yeah, but you
run the smoke test.
That's true.
We'll run the smoke test when we are merging any of our production branches into the development branch.
Okay, if you have a development branch, not all groups here have development. Some have feature branches and they merge into master branch. If you have a development branch, you do it when merging into development because the concern there will be that you'd be getting, if it's not fit for use by testers and developers, it's not fit for merging into development. And you would want to have that as the point you'd want to do the smoke test. Because otherwise, what you don't want is this to merge to occur and suddenly a large fraction of developers or testers are unable to do their work, right? Because they can't even log into the system for system tests. They can't even, try out some integration tests that operate with data from the database because the database connection is so messed up. And in which case, you don't want those changes that have been introduced in this case into the dev branch. So, and you're going to want to roll this back until these issues are sorted out. But it's a pretty low bar in the sense there may still be unit tests that fail and some integration tests that fail in areas of the application, but basically others can continue their work. Is that helpful? So that's a smoke test. The idea of a smoke test. And what's that? Was there another? Was there a vocalization? So here, I'm trying to distinguish why you don't want to confuse the entire test suite with the smoke test. You generally want to separate the two. Yes, so Connor.
Would your smoke test then be like a subset of your tests, or would it be like you pick a certain test, this one's going to be a smoke
Yeah,
test?
that's fine. Yeah, folks, it doesn't have to be a separate test. And in fact, it would be a bit perverse if the tests in the smoke test weren't also part of the test suite. So generally, the tests in the smoke test are going to be a subset of the system test. And they'll just be a thoughtful subset that provide basic, it's a sanity check. They basically rule out the system so hosed that it won't, you can't basically use the most fundamental features of it. And so it'll be, maybe it's 2 or 3 of these. It could be 5 of them.
It doesn't have to be like a huge bunch.
It doesn't have to be a huge bunch, and it's got to be automated.
Right.
Like
It has to be like a workflow type of thing.
yeah, if it's manual work, if it's manual, you've got to have like different people staying up, ready at any time to do the smoke test, right? And people. They're like the smoke test sentry, they're up at any time holding vigil for the, you don't want that, right? You want an automated system if at all possible. And there should be someone who quickly fixes the build. If the build breaks, if the smoke test breaks, you've got to have someone who's ready to roll it back and then fix the build, like go in and fix it. Or if another way to do it is it's merchant main and have someone go in and fix what happened. So really the person whose pull request is being merged into main or moved into the dev branch, the person responsible for that should monitor, does the smoke test work? And, is the build working? If the build is broken, they've got to fix it, right? Now, I should emphasize that the smoke test is not the only validation step that occurs for these merges into dev or into main. Like there's the build itself, right? There's the compilation step for languages which are compiled. And if that breaks, you've also got to go and fix it as soon as possible and either roll back or you've got to you've got to fix it in place.
Right.
And, you know, and fix that compilation issues.
A build wouldn't be a smoke test. That's the build itself. Like a smoke test wouldn't be if it builds.
So,
You know what I mean?
so if it compiles, that's not in any way testing its runtime behavior. It's
Right.
not testing its behavior that's dynamic. It's behavior as it runs. It's
Okay.
testing that it's type safe. It's testing that it meets some basic, you know, that it parses, that it's like it's grammatical. That doesn't mean it's meaningful, right? Like I can read text, hopefully not in this class for students, that's grammatical without it being meaningful, right?
Mhm.
Noam Chomsky is, you know, a famous sentence. What is it? So something green ideas sleep furiously. I mean, it's a perfectly grammatical sentence. Its form is sensible and meets all the rules of English, but it's semantically nonsensical. And what a compilation will generally check is just, is its form acceptable? Except it will also do analysis with types, okay? And it will make sure it's type safe. And that's why, oh, please, I urge you, I beg of you, I plead with you, I implore of you, I exhort you, I order you to make sure as you're using types that you use types to good effect by not just using any for all types. If you use any for types, you will cause me embarrassment. You may cause me distress. You will give me the heebie-jeebies and maybe the willies, and you may give me nightmares. So like use types to good effect. You know, typing is in place in TypeScript for a reason. It's in place to help guard against code that whose form looks reasonable but is semantically nonsensical. And types they don't provide a guarantee that it's working fully, but they provide more guarantee than just compilation of the form. They make sure that you're not doing something crazy like giving a string where a double is needed, or giving a double where a value that's a Boolean is expected or something like that. Types provide a very basic level of testing of in languages like TypeScript that it's sensible, but then you've got to test it further with other tests. The smoke test is just a subset of system tests to check if the system is so broken you declare it unfit for consumption and someone's got to fix it real quick. Yeah. So Connor.
Oh, you answered my question.
Okay.
Yeah.
Hmm.
I was gonna say it's okay to use any sometimes, but no, never.
Well, I'm not going to say never, but what I don't want to see is 80% of the uses of types in your system be any.
Yeah, you might as well use JavaScript.
Yeah. And I'll just leave it at that. Okay. Enough said.
Yeah.
Do not leave that. Now, if you tell me you've switched recently to TypeScript and that was the starting point, okay, fine. But let's sort that out as soon as possible, because you're leaving money on the table. You are blinding yourself to whole classes of errors that could be discovered if you pay attention to types. Types are your friends. Yeah, got it. I can't afford to go into a soliloquy like this. We have too much.
Fair. Okay.
Types are your friends, and types can head off many kinds of runtime problems if you use them to good effect. Yeah, in other words, they will find errors that would only otherwise be found through great efforts with testing or peer review. Types can head off the risk of that immediately. And so they are a key ally in helping to raise confidence that a program is specified in a way that is That is correct.
It wouldn't make sense to have an assertion though being like, oh, this is a number versus a string, because the type is gonna find that anyway, so the
Correct.
assertion will be redundant.
Correct. Okay.
Okay,
Now
yeah,
you're
right,
bringing
yeah,
up
come on,
nightmare. So. Yeah. So. There have been many funny points in my career here where one time, when the first time I taught this class, I looked at some of the code the students had produced. I didn't know, but my department head was walking down the hall to my office. And I like leapt up from my desk, looking at this code. And he like appeared at the doorway, saw me leap up. And I said, like, can you believe, like, can you believe this code? Like this thing given. That was one vignette. Another occurred with an impassioned soliloquy I gave, which one student declared was the finest point of his 4-year university career. was being exhorted by me. But there were other times where on my exam. So I've seen this a lot. Please do not give this to me. Please do not, for God's sake. Oh gosh, where like I say, give me 10 tests of this code, 10 well thought through tests that manipulate texts, and like almost all the tests are like, okay, this code takes 2 double values as its argument, and it's saying like, are these values given to me really really doubles at runtime? Look, tests, the job of tests is to test behavior at runtime. Type systems enforce that you will receive something of the correct type. You do not have to check that at runtime that it's a member of the correct type. It wouldn't compile if that were the case.
Right.
But the code was filled with these things like, testing is the type of this really, really a double, really an int. And that's totally unnecessary.
Right.
In fact, it adds no value. It's a distraction from using your efforts where they're needed. And this is about, you use the right tool for the job. Part of what the job of typing is to rule out broad classes of errors so you can concentrate in your testing and your peer review on other sorts of errors that wouldn't be caught. And you can focus your efforts on things that require more attention yet. And that's what good attention to types in a system is. And this is why you want to pay attention to using types to your advantage. Yeah. Now, the types in TypeScript have some basic features. They have you have union types, you have structs or product types records, and you have some good support for polymorphism and so on. All these things are good, but there are languages where the typing is at a higher level yet, and you can catch things that otherwise you would think require runtime reasoning. So, for example, you can have a type that says the length of this list is, so you take 2 arguments, one is an array and one is so the first one, say, is a number n. The second is a array that has to be of length n, and the type of it can be given to be a type, an array of length given by this value n. And that allows you to reason about the code, the subsequent code, to rule out, for example, out of bounds accesses for the array, which can mean that it can compile the code much more efficiently. And higher levels of typing can help spot these problems, and can help rule out problems so that it can be much more efficient in its compilation. So, yeah, I'll just leave it there. So are people clear about the basic job of smoke tests? And I do want to emphasize that smoke tests are a subset of system tests, and generally what's in the smoke test will be in the set of system tests. It's a subset that confirms the very highest level of functionality for the low bar in the sense of checking very basic things. Is the system in a sane enough state that it's worth people building on? Is it fit for human consumption? Very basic criteria. Are we good with this? Okay. So that was my comment on smoke tests.